Alrighty guys, so just to get you guys familiar with my setup and how I went about this test, I just want to show you guys what I did in Fusion. We'll get into the actual program, and then we'll go watch it run on the machine. So starting off, I made this sample piece. This is actually a piece of scrap that I had in the shop. It's about 2 inches by 4 inches tall, or long I guess, and then 625 thou thick, which is, I believe is 5/8. I just basically drew that out, extruded it up, just to create that sample that I had, and then I put this 1/4-20 hole in there. I just used the hole feature, and if we go in there, we can go and verify it was a 1/4-20 hole. Take it out here. All right. Yep, 1/4-20 hole. Put that in there. You can also specify the class. I don't know if this is meant for when you're doing drawings. I don't know if it actually takes that into account when you're in the manufacturing section, but either way, I just specified all of this. You could do, 1B, 2B, 3B, whatever. And also left hand, right hand, whatever the specs are, the dimensions that you want, you can put that in there, of course. So we do that. I made that, and then go down to manufacturing section. You can see that if I turn the model on, I did my setup. I made my 0 right at the top of the surface and then right at the hole. I did this kind of strategically so I could, if I needed to, reset up my 0, just, reset my XY over here, and then just re-drill if I needed to, if I broke a tap, if I had any issues, I could just program it like this and then just change my fixture offset, and then I just drill and tap and just be set to reiterate and keep going and to develop or make sure that rigid tapping was working on my machine. So going from there, I made my X and Y 0 at the hole, and then Z is on the surface of the part. You can go into here. We see the center drill. I'll try and rotate you guys around so you guys can see it. Got the center drill, then we got a number 7 drill, and then the 1/4-20 tap. This is actually, this drill and tap actually came in a little kit. I went the cheap route. I wanted to, if I failed, I wanted to waste as little money as possible. So I actually went to Home Depot and bought DeWalt has a 1/4-20 drill and tap set. I just bought that so I could just test it. If it breaks, oh well, I lost what, $5-10 bucks, however much it cost, instead of going to the Harvey tool or helical and buying, I'll say quote unquote fancy stuff. So fail cheap, and then I can move on. Luckily, as you guys will see, I succeeded in this, so that was awesome. So I have more confidence I can go out and buy good stuff, actual like a spiral tap instead of the straight flute. So going through this, the one thing you'll notice is if you go into the tapping section, if you select a tap, all you have for feeds and speeds is really just the spindle speed, when normally for the drill you would have a whole selection of stuff to do. And actually this is 200. I actually went 100 in my first test and you guys will see this, but as a super conservative, I always wanted to watch that spindle go nice and slow inside and come right back out and make sure I didn't miss anything, nothing crashed, whatever. So 100 super slow. I think you could go up to 1,000, or even probably higher than that. I think I've seen machines go up to 2,500 maybe. Super fast, super awesome, but I'll get there someday. So we do that. You can see, actually we'll do a little simulation here. We'll generate everything real quick. So we go to simulate. We'll turn the model off, and then it's going to be super fast, super quick. It's basically just three drilling operations, nothing too fancy to see here, but it gives you an idea what we're going to see in the machine. So that's simulate, And then we are going to, let's go ahead and post this. Let's close this out. We're going to post-process this. This is also using the Fadal post straight out of Fusion 360. I didn't need to change anything, or at least so far I haven't needed to change anything. You could if you went into OpenConfig and then start playing around with the post. If you're not familiar with that, I wouldn't recommend going in there, but just using it the way it is, I haven't had any issues so far. So we're going to post this. We're actually going to call this quarter 20. Let's do 2520. So let's post that. I'll just post it into my NC folder. And it's super nice with the FTP setup on the machine. I can just take the program from here and then save as or send it to the FTP and then just pull it up on the machine and drip feed it in. It's so nice. If you don't have FTP or any way to remotely send files to your machine or Fadal, I would highly recommend it. It's awesome not having to deal with USBs or trying to send stuff back and forth some other way besides just over the network. It's amazing. So before we get to the machine, let's go over the code real quick, and then I'll show you guys the actual running. If we look at the beginning of the program, you'll see that there's a bunch of this boilerplate stuff. Goes into the comments, which is what tools you're using. You'll notice that I start at tool 2, 3, and then 4. That's the center drill, and then the tap. Tool 1 for me is always my Heimer. And I'll be doing a later video on this, on why that is. Through our community of Fadal users, I've found a great setup that I want to be able to share with you guys, make a video of it. But I use tool 1 as my Heimer, and that's always the case, so everything starts at 2. If we go down a little bit further, you'll see G90, G94, and then G17. What that is, if you guys aren't aware, is that's absolute mode, which is the G90. G94, that's a standard command for Fadal. That's the feed rate spec, saying that we're going inches per minute, and we're not doing the inverse time feed rate. G17, which is another generic one that's seen across many different machines and controllers. That's the XY plane selection. G20, that is the inch specification. We're not doing in millimeters, we're doing inches. Then we get into G28, G91, G0. That's basically return home, go back up to that Z0 position. And then G90, calling out absolute mode again. We get down into the center drill and drill section. These are very similar, so I'm just going to go over the center drill real quick, and then we'll hop into the tap section. So we call out tool number 2, and then we call out the spindle speed. After we load that tool, we're going to M3 is clockwise rotation, and then we're going to go up to 5,000 RPM. And then we are going to dwell. This is a very short dwell. I think this might have to do with something with the controller. It's only on the center drill, but it's dwelling 36 milliseconds. And G4 is, of course, the dwell command. Then we go down to M8. M8 is turning coolant number 2 on. If you were to want to turn on the coolant number 1, that's M7. Then going down, we have G0, E1, X and Y0. That's basically a rapid move. We're going to be calling up fixture offset number 1. And then go into X and Y0, wherever that's specified. For us, that's the center of the hole. And then G43. G43 is the tool length comp in the positive direction. Then we're going to call out, we're going to this Z value, which is Z 0.6. And then H2, of course, corresponds to the tool that we have. We have tool number 2, so we're going to have the offset. We're going to use offset number 2. Then we're going to go down to Z 0.2. This is I think the feed height. And then after that, we're going to start calling the actual drill command. So the actual drill command is G81 X and Y 0, and then Z, this Z depth. R is the actual, it's called the R plane in Fadal. That's where the actual feed starts, what that height is that it starts at. So it's going to start at 0.2 and then continue feeding until we get down to this Z depth. And then here's the actual feed rate. I skipped over this command because I want to explain this. This is the actual drill command, and then G98 is return, what's the actual, return to initial plane is what it's called. And that basically means after you do whatever I command after this, just return back up to that Z height that you're at. So that's what G98 is. After we do all of this and we return back up to that plane, then we go to G80. This basically says, hey, turn off whatever fixed cycle that you're doing. Then we're going to go up to the Z position 0.6 inches. Then we're going to turn the spindle off, that's M5. And then G28, G91, Z0, going back up to the home position, and then calling out absolute mode again. So that's basically the same thing down in the drill section. You'll notice that there's slightly different numbers, for Z depths and the feed rate. And then this also calls out the coolant off command, because it's got to change the tools out, so that's always good to not be spraying coolant around. Just change out the tool and come back in, and it'll turn the coolant back on, which is M8. So that's the center drill and the drill section of the code. And then here's what we're all waiting for right here, the rigid tapping section. So start off, we're turning off the coolant. So after we drill, we're going to turn off the coolant. This is the optional stop. If you got that flip switch on the front of your control, I'll say activated or turned on, then it'll wait for you to push the start button so it can change the tools. If you don't have it on, it'll just skip right over this, ignore it, and then go and pull tool number 2, and then start to spin up. We are going to go to, this is called out as the spindle speed of 200 RPM. I actually did 100 as my initial test. Super slow. I know I've seen machines go up to 2500 RPM. That's pretty awesome. But we're going to go up to 200 RPM, and then we're going to turn the spindle off. I don't know why this is in here, but I think it might just have to do with, getting stuff set up, because you'll see later a few lines down this G84.2 command. So we're going to go up to, we're going to specify 200 RPM, then we're going to go to M8, which is the coolant on, it's coolant number 2, then G84.2, this called out in the manual is what's used to prepare the machine for the tapping command. So that's called out, and then we call out G0, E1, X and Y0. That again is a rapid move in the fixture offset number 1, X and Y0. Then we're going to call out G43, Z 0.596, this crazy number right here, basically 0.6 H4. What that is the, again, tool length offset in the positive direction. This is the clearance plane, and then this is the offset for the tool 4, that length offset. Z4 or Z 0.4, that is our feed rate plane. In the actual manual, you'll if you read it, I'll put links down below. But this is called out in Fadal. They want your feed rate plane to be 0.4 above your material that you're gonna feed into. I think this is just to allow it to spin up to the RPM specified before it gets down into the part. And then again, here we go, G98. after we do whatever we specify after this, go back up to the plane that we were just at. So here's the rigid tapping section of the code. G84.1, that's the rigid tapping command, right hand tap. And we're going to X and Y 0. Then we're going to go down to the Z depth. Going to go all the way down to the bottom of that 5/8 bar. Then here is our R plane. We're 0.4 inches above the part. And then calling out the spindle speed and then the feed rate. Going down to the next section, G80, turn off all the fixed, routines that we were just doing. So in this case, the rigid tap section. Turn it off. Then we're going to go back up to our clearance plane. And then we're going to turn coolant off, return back up to our Z, call out the absolute mode, and then call up the machine position, go back to the machine work plane, go back to X and Y 0, and then here's the end of our subroutine. So that's pretty much it. So I'm going to go ahead and send this over to the machine, and let's go make some chips.
Alrighty guys, so if you guys follow me on Instagram, you've already got a sneak peek of this, but we're going to do it for our YouTube friends. We're going to go over here, go to CD, 10. Going to go get on that FTP or get those FTP files. CD, 10. Then we are going to, we know that we can actually go back. We'll go to directory. We'll make sure that our program's in there. Oh yeah, see, 2520, our quarter 20 rigid tap test. So we're going to call out again. CD, 10, enter. Then we're going to go DNC, then 2520.nc, and then I'm going to push the plus sign. That's now going to, it's waiting for us to push start, but once we push start, we're going to start doing stuff over here. So let's go ahead and push the start button. We're going to start changing tools. Alright. I got the feed rate all the way down. Let's turn it up. There we go. Center drill. It's going to be super quick. Going down. And I'd love to show you guys inside the machine or have you guys set up, but my GoPro, I don't have a case for it anymore because it broke. See, it's waiting for us. Oh, we got the optional stop on. So we're going to just push start. It's going to go over. Change the tool. We're going to now do the drill. We're going down. We're drilling. We're going to come back up. And I'm going to wait for us. I'm going to push start again. Go pick up that tap. And then here is the magic. Here we go. Let's see if we can get a good clear view of it for you guys. Here we go. We're going to go all the way down in. Oh, we're only going 100 RPM. We could go a lot faster than this, but I was just doing a test. Now we're going to back out. And then we are all done. Ta-da! So if we get our handy dandy airline, try and do this one-handed. Sorry for the noise if that was loud. We're going to take our bolt and we are going to thread that guy in there. Yep, there we go. We have ourselves a 1/4-20 tap. So it is a you know, Chinesium tap, DeWalt, probably made in China. But now that I've done this, I confirmed that, you know, everything works. I got confidence to go buy some higher quality stuff. I gotta work on my feeds and speeds apparently with my drill, but we'll get there. So yeah, thanks for following along, guys. Hope you guys learned something like I did. If you think this deserved it, please give this video a like, or heck, you know, if you think it even really deserved it, you know, subscribe to the channel and help me go along and share the knowledge of Fadal and machining and all this fun stuff that I like to learn about and share with you guys. So anyways, if you guys want to follow me more, follow me on Instagram, same name, just on Instagram, PGW Machine. And until next time, guys, I'll see ya. Have fun.